Hello, I hope you're okay. I'm going to be talking about SSL pinning today because I've recently put it in my iOS apps and done it on some server stuff. Thought I'd explain how it works, what it is, what it prevents against. So, I've drawn some diagrams. I've really copied Theo here in Excalibur and drawn some diagrams. So, say you've got your iOS app. This being your iOS app, it's doing, I don't know. I've got my phone here. Let me open an application. I don't know. I've opened an application. So I've got my Sky Q remote. This is loading. Sky Q remote. It's got buttons on it. Simple. You want to make sure that that request only ever ends up at your server. It's a bit like banks and stuff do this. So that you can't look at the traffic or you can't intercept the traffic on the way, etc. So when this app makes a web request, let's go to red and let's draw another arrow. That web request goes down this pipe all the way along to the server, where the server then sends back a response. The response has come back. That's green. That's both word. Because the request has been terminated at the server. That's where the TLS, or the checks about who it is, have happened. The web request has gone from the client to the server. We can now demonstrate this with some code. I'm going to demonstrate this with some code. So, if I just comment this out, and this out. This is a standard bit of code. It's going to go to this endpoint, which is just an endpoint that looks like this, with some JSON, it'll return some JSON, etc. So if I just run that in the command line, it says SSL pinning successful, but that's just the response message. Look, it just says SSL pinning successful, because we're going to demonstrate this with some SSL pinning in a minute. Excuse me, the request has worked. You can see here it's formatted badly, I don't know why, but it just says quote stay. Well, let's just drop this. Just drop this. Let's do this again. Sorry. Let's drop this. So there you go. There you go. Now it just says response okay, because we're just getting the okay message. It's worked. The request has worked, and we could see this in Proxyman that the request just went through and we got the response. You can see we made a get request to that endpoint and it proceeded. And it proxied and it says okay. So actually, I've not done this because as you saw here, I can see the request. I've given it some proxy settings to go via a server. It's going via a server. So actually, I've done this top request. Okay. So if I select this one and let's do red. So the request has come in to the man in the middle, which actually has terminated here. Let's go back to black. Okay. Which terminates here the TLS. This then makes a new, completely different request. I'm clearly not used to this. A new, completely different request that goes this way. The server. The server responds. There is then another request line. So the request has gone from the app, or in my case this bit of code, to the proxy. The proxy is terminating the request. So it's exposing the traffic and it's then redoing the request to the other side. So request coming in, getting terminated, going to the server, coming back, and then you need another arrow coming back this way. So actually, in the middle, whatever the web traffic is, which is just here, it's just a load of garbage. Nobody can understand it here. Here, it's complete plain text, and it says OK. You can read all of the information like you can here. That means that if there's a proxy in the way, the request has been successful. So this is secure. All of this is secure and all of this is secure. The Mac is trusting the certificate. We can look at this online. Let's look at this online. So connection is secure. The certificate is valid. So it's trusting that this proxy man certificate is valid for the common name thomas.net because the Mac has been sold to trust it. You can do that. You can do that sort of stuff. But your application, say you're building a banking app, you want to guarantee that the request is that certificate. not somebody else. You don't want it to just be able to be interpreted. So I can show you this. So if we add back these lines of code that are coming in and out, I think it's there. No, it's this. Coming out. Copy this. Put this back in. So now it'll still work as far as I'm aware. That still says SSL pinning successful. Response is okay. So here is the certificate in a SHA-256 base 64 encoded. So take the certificate, download it, SHA-256 it, and then base 64 encode that, and then you get this string. Simple command. I got a command here. Do this. Turn it to public key. Decrypt it. Base 64. SHA-256 it. Base 64 encode it. This is what you need to do to get the value, and then just add this SHA-256 bit. So this request, this is the base 64 encoded value of the proxy of this thing. So if I tell it to disable proxying for this domain, I don't know if that will work. Let's just check. Tools, SSL proxying list. So as you can see, I'm proxying a lot of stuff. That should hopefully have worked. We'll just do this again. That's clearly not worked because it's clearly still in plain text. What's doing the proxying? Give me a minute. So the request is still being terminated by the proxy. To you guys, it'll be obvious. Somewhere here, it'll say... wildcard anything at times.net. Okay. See, now, the request was successful through the proxy, indicated by this little green dot, that they actually worked. The proxy didn't know anything about it, like it did with this one. I just knew it's a connect request. And this has said that it's failed. That's because this is expecting the certificate to be that proxy. So if I change this, and this is now the certificate from the server, the proper SSL certificate. So if I reload this page. Oh, this is still... Interesting, that's still the... I might be proxying traffic for that domain. For that as well. Hold on. Google Chrome. Turn that off. Now that should... So now this is from Let's Encrypt. This is the proper certificate. The actual network issued trust certificate. Now that I've put this as that, meaning this is the trust, I know that this is the base 64 of the public certificate. When I do this, it says it's okay. But as soon as I try and proxy this domain, it don't like it. It will not send the traffic through, and you won't see it here. Sometimes you see it here as a failed request. If you're doing it on iOS, it attempts and it does it as the next step in the process, but this has done it differently. Why? You're thinking, why do you want to do this? Not all applications require it, don't get me wrong. But if you're like a banking institution where people looking at the traffic in between or editing it, so of course the traffic here is encrypted and it's here is encrypted, but this person, if they have access to the device, can actually make it so that they can view your web traffic. This is a bit like how if you're at a school or whatever, if you're at a work institution, they block some websites. They might be doing proxying, and a lot of people block these domains by not allowing SSL, by doing SSL pinning. It's very common practice, and it's really good because it means that you can guarantee the web request coming out of the app is what's hitting the server. And yes, okay, in some cases you can swizzle and stuff like that around it, but actually it blocks a lot of traffic. So let me explain to you now how to do this yourself. So we're going to do this PHP example. I'm not going to show you any like Swift code or something like that. I'm just going to show you how I did it. I'll just explain it to you quickly. So of course we've got this server-side code. I've got this URL. I'm going to go here. Just simply I'm going to download, I'm going to export. I just need to go to the desktop. I went for base64 encoded ASCII single certificate. I won't really do that because that's what I did. I then ran this, which converts it to a public key and does some stuff. That gives me this value. This value is what I put here. Expected cert value. And then I've, in curl, which is a thing in PHP, I've added the pinning public key. Set the pinning public key. The string can be a file name, can be the file name of your pin public key, file formats. The string can also be a number or base64 encoded sharp, blah, blah, blah. So you can also have more. So you could separate it by colons. So if you had more than one certificate. So essentially, you could do this with the intermediate certificate. So how can I explain this? This might be a good example. So on Excalibur has a web certificate whose details are made by Let's Encrypt. Let's Encrypt has a root certificate, this R10 certificate, which is then signed by a root internet authority. You could say, if you had a root certificate, if you had a root certificate, say I had one at thomas.net, which I do, you could make sure it always had that in the chain. Essentially just check that the chain contains that. Meaning anything signed with that, regardless, was a trusted thing by your application. Yeah. I hope this has been interesting. I've enjoyed explaining it to you. I'm trying to do more. I'm trying to do more YouTube videos. If you stayed around, thank you. Thank you. It means a lot.